You multiply complex numbers a plus bi and c plus di as you would multiply binomials. For pure imaginary numbers, bi and di, bi times di equals b times d times I squared. Now recall I squared is negative 1, so this becomes bd times negative 1, or negative bd. An example, 7i times 9i, well, that equals 7 times 9 times I, that's 63i squared. I squared is negative 1, so 63 times negative 1, or negative 63. Notice that the product of two pure imaginary numbers is a real number. Problem 4. Multiplying complex numbers. What is each product? Part A, 3i times negative 5 plus 2i. We'll use the distributive property and distribute 3i to both the real and imaginary parts of the complex number on the right. 3i times negative 5 is negative 15i, and 3i times 2i becomes a plus 6i squared. Then we'll substitute negative 1 for I squared. That brings us to negative 15i plus 6 times negative 1, and we'll simplify, writing the complex number negative 6 minus 15i in its standard form. Part B. How about the complex number 4 plus 3i times the complex number negative 1 minus 2i? Well, we'll multiply. We can think about distributing the real part from the first complex number, 4, to both the real and imaginary part of the second complex number, negative 1 minus 2i, and then distributing the imaginary number part, 3i, to both the real part and imaginary part on the right. Or we can use FOIL, as we've seen before, multiplying binomials. Negative 4 minus 8i minus 3i minus 6i squared. Substitute negative 1 for I squared. That's negative 4 minus 8i minus 3i minus 6 times negative 1. And simplify, writing the complex number in its standard form, real part first, followed by imaginary part. That's 2 minus 11i. Part C. Negative 6 plus I times negative 6 minus I. Well, we'll multiply. That leads us to 36 plus 6i minus I squared. Then we'll substitute negative 1 for I squared. That brings us to 37. Your turn, part A. What is 7i times 3i? Part B. What is 2 minus 3i times 4 plus 5i? Part C. What is negative 4 plus 5i times negative 4 minus 5i?